Hello everyone, welcome to the live class. So guys, today we are going to have another very important session in which we will be discussing some more important questions, concepts and the points, or wherever the tricks will be possible to consider, we will be taking those tricks too. So this is how the session will be helping you in all ways and will be helping you to take your preparation to a very good level. And guys, we will be starting the discussion soon. Let me just check whether everything is all right and clear your side or not. And after that, we will be continuing the discussion as well. I think everything is all right and clear your side too. Let me just check the audio once. Done. Okay, so when we are having everything clear and okay, we are ready to proceed further. We can talk about so many important things, and after that we will be continuing the discussion to consider the important questions, concepts and the tricks. So let me just start that discussion. Before starting the discussion about the concepts and the points, the questions, I need to show you some important slides, and after that we will just be continuing the discussion. So let's consider some of the important slides here. These are some of the details about me. Here we are going to have the information about the community feature we are having on Unacademy, which will be helping you to get the new or the latest updates about the new courses and many important points. Okay, so this is how we are going to have all the details mentioned here regarding this. Now, if I'm going to talk about the another important thing here, that is regarding the iconic subscription. If anybody will be taking the iconic subscription, then what are the details or the benefits they will get, okay, or the details they need to know about. All the details have been shown here on the screen. Even now the notes are available on the learning app, which will be helping you a lot to take your preparation to the next level under the guidance of top educators. And whenever anybody will be proceeding further to take the subscription, guys, you can use and apply the referral code, that's Anjali Live, as mentioned here on the screen, because whenever you will be using and applying this referral code, you will be able to get the discount in the total subscription amount. This is regarding the plus subscription. What are the benefits you will get if you will be taking the plus subscription? All that has been shown here on the screen. And again, the referral code has been mentioned here, which will be helping you to get the discount in the total Unacademy subscription amount. The difference between the Unacademy Plus, Iconic and the Lite subscription has been shown here on this slide, which is even important for everyone to know. And guys, depending on this part, that what are the differences we are going to have on different subscriptions. Okay, if you will take Plus, Iconic or Lite, you can just decide which one you want to take, which one you find more beneficial for you, and accordingly you can just proceed further to take the subscription. And whenever you will be proceeding further, use and apply the referral code, that's Anjali Live, as it has been mentioned here on the slide. Let's continue the discussion now about the Lite subscription. All the details have been shown here on this slide too. So I hope now each and everything is clear to every one of you. We are ready to talk about the important questions and the concepts now. If in case you will be having any question, query or doubt anytime, you can just mention it in the comments and we will be talking about it. Okay, so let's continue the discussion and let's talk about these points. Just a second guys, I'll start giving you the questions and I'll be telling you the first question we are going to consider here, so that we will get to know that what concept is involved, is this related to some trick, and everybody will be getting to know about these things. So let me just give you the first question right now, and after that let's continue. The session is important for NET and GATE, both the exams. Okay, so whether you are doing the preparation for CSIR NET exam or you are doing the preparation for the GATE exam, it will surely be helping you. One more thing guys, in upcoming days, so many new courses by the top educators will be starting on Unacademy. So in case if you want to join these important courses, the batches and all, so in that case you can take the subscription so that you will not miss these important and the new courses classes, and you can continue your preparation or take it to the very good level. So this is how everything will be helping you. Okay, let's continue the discussion and let's take the first question here. Along with the questions, I'll be talking about the concepts too. The first question is, the Hamiltonian for a particle of mass m is h is equal to p square upon 2m plus kqt, where q and p are the generalized coordinate and momentum respectively. T is time and k is a constant for the initial condition q is equal to 0 and p is equal to 0 at t is equal to 0. Qt is proportional to t to the power alpha. The value of alpha is, and this is going to be a kind of NAT type question. Okay, so in that case, as anybody will be getting the answer, they can just mention it in the comments directly that what is the right answer according to you, and whatever you are gonna get, okay, just mention it. Very good morning, Anuradha. Very good morning, everyone. So as anybody will be getting the answer, guys, just mention it in the comments. I think it's not visible what I have written here, so I'm just going to write it here too. Qt is proportional to t to the power alpha. The value of this alpha you have to find. Okay, just proceed further. Also, guys, after this session, one more session is there today. So after exactly this session, our next class will be starting too. As anybody is going to get the answer, mention it in the comments that what is the right answer according to you. Also, guys, today evening we will also have one more marathon session. Okay, here itself, that is Unacademy live CSIR UGC net, so you all can join that too. That will be for mathematical physics, and around 7:30 p.m. we will have that session. And today, after this one more session we will have. Okay, so this is how we are gonna have these important classes on Unacademy live CSIR UGC net. You all can join these important sessions too. Nobody has mentioned the answer till now, guys. Waiting for your reply, and just in some time I'll be continuing the discussion too. Or whatever answer you're getting, mention it, mention it, mention it. Okay, let's continue the discussion, but before talking about this question's answer, I would like to talk about some of the things like concepts in the formulae part, okay? And after that, I'll be talking about the answer of this question, because the main thing is, if you know the formula, I think it will be quite easy for you to get the answer for any such type of question. So instead of talking about the direct answer, it's important to talk about or discuss the formula and the concepts as well. Very good, Anuradha. Whether we will be deciding in just some time or finalizing it by solving it together, whether it's the correct answer or not. But you have tried, and that's great. So if I'm going to talk about the formula of classical mechanics part, okay, so you need to know one thing, guys. That's going to be, we are having the main initial topics which we will be considering and I'll be discussing right now is the Lagrangian and Hamiltonian. So when I'm going to talk about the Lagrangian, what are the things you need to know about it? That's going to be, the Lagrangian is a function of generalized coordinate, generalized velocity and time t. Okay, while Hamiltonian is a function of generalized coordinate, generalized momentum and time t. Then next thing, the next is going to be L is equal to T minus V, which is kinetic energy minus potential energy, while Hamiltonian is kinetic energy plus potential energy. Okay, next thing, here we are going to have the Lagrange's equation of motion as d by dt delta L upon delta Q dot minus delta L upon delta Q equal to 0. While in case of Hamiltonian, we are having the two different Hamilton's equation of motion. Now what are these Hamilton's equation of motion? Let's come to that part. So basically these are going to be Q dot is equal to delta H upon delta P, and P dot is equal to minus delta H upon delta Q. Okay, this is what we are going to have. Now next thing, if I'm going to talk about the next thing here, what is that? That's going to be after considering, just a second guys, just a second. Yeah, after considering these important formulae and the expressions, we need to talk about some related formulae with the Lagrangian and the Hamiltonian, both of them, because they help us to consider the important parts. Okay, so d by dt delta L upon delta Q dot minus delta L upon delta Q equal to 0, and these are going to be the two Hamilton's equation of motion. Next thing, one additional tip or one additional point discussion we are going to do here, which will be surely helping you at so many different places. You know how the force is related to potential in general, but what about the generalized force? If any time you have to find the generalized force, how you will be finding it and what you have to do for that? You will be replacing L with V in the same equation, that is a potential, and that will be giving you the generalized force. Simple and easy way of memorizing that expression and the formula. Okay, I hope it's getting clear, and if yes, this is how you can easily get the generalized force expression too. Okay, some additional tip here. Now next, if we are going to talk about the another important formula, that is generalized momentum, what it will be, delta L upon delta Q dot is the generalized momentum formula. Okay, now next, if we are going to talk about the next thing here, that's going to be when we talk about the Lagrangian and Hamiltonian, both of them, there is a relation between Hamiltonian and Lagrangian, and what is that? That is even important. qi dot summation over I, because sometimes you can have more than one coordinates involved in the given system, for example x, y, z, like that. So qi dot pi minus L, okay, one of the expressions. Other than this, if I'm going to talk about the another part, this is the relation between Hamiltonian and Lagrangian I have just mentioned here. Next thing is, if I'm having the Lagrangian given and I want to just check it out, what is the cyclic coordinate? Now what is the meaning of the cyclic coordinate? Let's say in the given Lagrangian you are going to have any coordinates first order derivative present, but the coordinate is not present there. So that particular coordinate will be considered to be ignorable. It has been ignored. The coordinate is not present there while its first order derivative is present there. Okay. So ignorable, or also known as cyclic coordinate. So when you are having any such cyclic coordinate present, you will say its corresponding linear momentum is conserved or constant of motion. Okay. That's what you need to know. Once you got to know about all these formulae and the expressions, now what next? The next thing is, let's go back to the question part and let's use these formulae to get the answer. But how and how you will be reaching to the answer, we'll talk about that. Also guys, q dot here is dq upon dt and p dot here is dp upon dt. So you can see what is the meaning of q dot, dq upon dt, and what is the meaning of p dot, that is dp upon dt. Okay, with respect to t differentiation is that. Now when they have given us the Hamiltonian for any particle of mass m, and this Hamiltonian is simply kinetic energy plus potential energy, because we know kinetic energy generalized form is p square upon 2m, and this will be the potential energy then we will have. Next thing, the where q and p are the generalized coordinate and momentum respectively, t is time and k is a constant. For the initial condition, that is q is equal to 0 and p is equal to 0 at time t is equal to 0. So whenever I will take t 0, I'll be putting q and p also 0. Now qt is proportional to t to the power alpha. They have given us a generalized expression. Now we have to find the value of alpha. So how we'll be getting it? Let's proceed further. Hamiltonian is given. How we can relate the q, that is the coordinate, with the time, with the first Hamilton's equation of motion, which is q dot is equal to delta h upon delta p. So I can write it as dq upon dt is equal to delta h upon delta p. I'll be getting p by m from there. So I will just cross multiply and integrate. I'll be getting q, okay, is equal to pt by m plus c. That's a constant, integration constant. At the same time, I am having another equation too, that is dp upon dt is equal to minus delta h upon delta q. So what it will give you? It's going to be minus kt. So what it will give you? P is equal to kt square upon 2 plus c after integration. Now you know when t is 0, p will be 0. So what it will give you? When you will put t 0 and then you will have to put p 0. So it will give you c equal to 0 as well. When you will put t 0 and you will get q 0, you will be getting c equal to 0 as well. So that means constants are nothing but 0. Okay, constant is here 0 as well. So that means I am getting q is equal to pt upon m, and I am getting that's p is equal to minus kt square upon 2. Now what they have asked us to find qt, q dependency on t, like that. So in this case, I just have to put the value of p in this expression. So when I will put that value, am I getting q is proportional to t to the power 3? Yes. So what is the value of alpha here, the power term? 3. So what is the right answer? It's not 1, it will be 3. But if you will miss this relation, the value of p or the expression, okay, you will get the answer 1. Then it's wrong, because p is also dependent on t and you are missing that part. Okay, so your answer will be what? It will be 3. I hope everybody has got it now, but in case if there is anybody having any doubt, just mention it. I'll be talking about that too. But if it's clear, that's great. We can continue the discussion and we can talk about those points too. Let me know. Is it all right and clear? I hope yes. If no, let me know. And if it's clear, we can go for the next question too. Let's take this one. Whatever mistake you are making, guys, just be careful about it for the next time. Right, and Radha, so be careful about that point for the next time so that you will not be repeating or making the same mistake again. Okay, and that's how, guys, these sessions will be helping you for some of the mistakes you can make in your next exam. You will get aware of that part by practicing the questions this way, by preparing or revising the things this way. I think it's gonna be very much helpful. Okay, so let's take the next question now. Even for someone it can be 1 point, for somebody else it can be other point where they are having the chances of making mistake. So it can be any question for you. It can help you to work on your weak points or the points where there were chances for you to make mistake. Now have a look at the next question. All the different type of questions we will be considering here, guys. Consider the Hamiltonian. That is h as a function of q and p, and that is equal to alpha p squared q to the power 4 upon 2 plus beta q square upon q square, where alpha and beta are parameters with appropriate dimensions and q and p are the generalized coordinate and momentum respectively. The corresponding Lagrangian options are 1 upon 2 alpha q dot square upon q to the power 4 1 upon 2 alpha q dot square upon q to the power 4 plus beta upon q square. Option C is 1 upon alpha q dot square upon q to the power 4 plus beta upon q square, and option D is minus 1 upon 2 alpha q dot square upon q to the power 4 plus beta upon q square. Try it now, as you're going to get the answer. Whatever is the correct answer according to you, write it in the comments. Whatever option is correct according to you. And if something is not visible or clear, tell me, I'll be considering that part. Whatever is the right answer, guys, mention that option in the comments. Mention it as you will be getting the answer. Waiting for your reply. Very good morning, Preeti. Or just in some time I will start discussing it, guys, if you're not gonna mention the right answer or you're not getting it. Try. Mention the right answer in the comments. Okay, Preeti. Very good, Preeti, but I'll be explaining it too. That what is the right answer, and let's have a look at this together, whether it's same option which you have mentioned or the some other one. Let's have a look at the question and let's proceed further to get the answer too. Consider the Hamiltonian that is given, okay, where alpha and beta are parameters with appropriate dimensions and q and p are the generalized coordinate and momentum respectively. You have to find the Lagrangian corresponding to the given Hamiltonian. Everybody knows about it. Hamiltonian is kinetic energy plus potential energy, and Hamiltonian is a function of generalized coordinate, generalized momentum and time t. So when we write its kinetic energy, it's p square upon 2m form we have to consider there. Very good, Anuradha, that's great. And rest is the potential part. So this is potential, while if I'm going to compare it with p square upon 2m, m value I'll be getting is 1 upon alpha q to the power 4. Just check it. If you have to write this part in the denominator, how you will take it? 1 upon alpha q to the power 4, so that it will come back to the same position after simplification. So m will be the same value. Okay, like I have mentioned. Now, if I want to write the Lagrangian, it is kinetic energy half m. M is this 1 upon alpha q to the power 4 and v square, that is q dot square, minus potential energy, that is beta upon q square. This is what you will have. So kinetic energy minus potential energy, and this is your Lagrangian, same as given in option A. Please tell me, is it alright and clear or not? This is one of the approach which gives us the answer so quickly and just by comparing the expressions. If you are doing it with the other approach, that's going to be L is equal to summation over I qi dot pi minus h. It will also give you the same expression. So any of the methods can be used and you will be getting the same answer with any of the approach, whether the trick, the comparison part, or the formula which I have mentioned here. So let me know whether everything is alright and clear or not. If yes, we can take the next question. If no, ask your doubt. Just mention it. I'll be considering that part too, and we'll be talking about that point. But if everything will be clear, we are ready to talk about the next question. Just a second, let me just give you the other one. can slide without friction along the rod is rotating about the vertical axis with a constant angular speed omega the momentum conjugate to R is options are, and I will also be showing you the figure. We can make it somewhere here so that it will clearly be visible to everyone. This is going to be z cap direction and this is going to be the x cap direction, and all the arrows and the important details have been shown here. This is going to be 45 degrees angle, this one, and this is R. Done. Now options are mr dot, next one is 1 upon root 2 mr dot, next one is 1 upon 2 mr dot, next one is root 2 mr dot. Try it now and let me know, as you will be getting the right answer. Whatever is the right option according to you, you can mention it in the comments. Try. Whatever you think you have to consider and you have to do to solve this question, you can start working on that part. I will be giving you some time, and after that I will start the discussion too. We'll be explaining each and everything to you. Try it now, guys. Very good, Anuradha. In just some time, we will be finalizing it. What is the right answer and how you're just gonna get it. But that's good that you have tried. Waiting for more reply, and after that I'm going to continue the discussion too. Okay, first of all, a bead of mass m can slide without friction along a massless rod kept at 45 degrees. Very good, Preeti. That's great, great, great. Two answers exactly matching with each other. Let me just check it once. You are going to get, let's have a look at the details of the answer steps and then let's finalize it. So one thing is, which coordinate system we will prefer to use? So in this case we will be using the, which one? What do you think, which one you will be using here? Mention it. Which coordinate system I should prefer to use here? A bead of mass m can slide without friction along a massless rod capped at 45 degrees with the vertical as shown in the figure. So the rod is rotating about the vertical axis. Rod is rotating about the vertical axis with a constant angular speed, okay, omega. At any instant r is the distance of the bead from the origin, okay, as it has also been shown in the figure. The momentum conjugate to r is, this is what we have to find. So you need to tell me, what do you think, which coordinate system will be the most suitable one and we should use here? Just mention it once and I'm going to continue that discussion, or I will let you know whether your answer regarding this question, that is the coordinate system to be used, is correct or not. Which coordinate system? Because see, at this point of time now, when you are solving any question, so you want to find anything like the distance, the height, okay, and anything like that. So what will be your first choice? Your first choice should be to write the Lagrangian, okay, if possible, and accordingly you can just proceed further to write or to get the data you want to get. And rather, till now, today we are just going to have the sessions here on Unacademy Live CSIR UGC Net, and one more session today in the evening time we will have, okay, that will be even for longer duration, so chances for the spatial sessions are less today. Very good morning. Organic M nuns. Let me know guys the coordinate system you will have to consider here. Okay, this is going to be the spherical coordinate system. Reason behind it, there is a bead which is moving, okay, and a bead which is sliding basically, and rod which is moving as well. So look at this, a bead of mass m can slide without friction along a massless rod kept at 45 degrees with the vertical, okay, as shown in the figure. The rod is rotating and bead is also sliding on it. So which one we have to consider? Preeti, this time right now classical, after this quantum, exactly after this quantum session will start, and yeah, after this quantum session we will have, this one is classical going on right now. And today in the evening timing we will be having mathematical physics marathon session here itself, that's on Unacademy Live CSIR UGC Net. So all these three are our YouTube sessions here only we will have right now. Okay, so one in the evening and two right now for classical and quantum, and mathematical in the evening time. Now next, so due to the motion of these two, the rod and the bead, we will have to use the spherical coordinate system. When we will be using the spherical coordinate system, our overall Lagrangian expression will be half m r dot square plus r square theta dot square plus r square sine square theta and phi dot square. Done. And next thing, minus potential energy. So what it is going to be simply mg r cos theta in general. As per this, if this is theta, we are taking as 45 degrees. So vertical axis mg h is the height we take now. So that will be what? R cos theta, and that's how we are just gonna get it. At the end, we will be putting the theta value to be 45 degrees. Okay. So when I'm saying theta is equal to 45 degrees, then this theta dot term 0. Okay, this cos theta cos 45 value you can just consider there. So this is how, when you will be simplifying it a little more, your Lagrangian expression should be half m r dot square plus, and phi dot I am taking as omega, which is the angular speed given in the question. Okay, further on, half r square omega square, because sine square theta is sine square 45 degrees. Again, you can do the normal simplification of this after putting the angle value. Now minus 1 upon root 2 mgr. This is what you will have. Clear? Next thing, if we will consider the next thing here, that's going to be, we have to find the momentum conjugate. That's our main question. So PR we have to consider. Okay, PR, momentum conjugate. What it will give you? It will be giving you the delta L upon delta Q dot. Okay, that's what you have to find, delta L upon delta Q dot. So when you are considering delta L upon delta Q dot, what it will give you? That is delta R dot. So 1 upon 2 mr dot, and upon 2 is already there. So I'm just going to get mr dot. This is my right answer, which is option A. There is no other thing we are going to have, just option A is there, and that's how you are going to get the right answer. So let me know, is it alright and clear to everyone now or not? Not option B, it's option A, which is the right answer we will have. Check it out and confirm it. Is everything alright and clear? Okay guys, tell me, is everything alright and clear? If in case there is something not clear to you even right now, just mention it. We can talk about those points. But if everything is clear, that's very good. Done? You got the right answer now. That's option A. And how you're going to get it, all the details about it have been discussed and considered in the discussion part just now. If there is any doubt, mention it. I'll be talking about it too. Done? Next one now. Next question is this one, which I'll give you. Here. A particle of mass m is attached by a weightless, inextensible string of length A. L as a function of theta and phi, that is equal to half m a square theta dot square plus sine square theta phi dot square minus mga cos theta, where theta and phi are the polar angles. The Hamiltonian of the particles is, options are, after this I'll be showing you the slide again if you want. Okay, even there is an image which has been given, so let me just draw it here. Dotted line, arrow, arrow. Then options are h is equal to 1 upon 2ma square p theta square plus p phi square upon sine square theta. Next we are going to have minus mga cos theta. Option B is h is equal to 1 upon 2ma square p theta square plus p phi square upon this is what we are gonna have. If you're gonna get the right answer, you can just select it or just mention it in the comments. I'm gonna show you the question slide too, which is here. Done. Try it now and let me know whatever is the right answer according to you. I will also be starting the discussion about this question's answer, but waiting for your reply first of all, and after that I will be continuing the discussion too, but giving you some time before that. Options are here, Anuradha. Okay. Let's. Yeah, very good, Anuradha. That's great. That's great. That's correct too. Let's even talk about it, guys, that how you will be getting the same answer. The Lagrangian is given, and it is going to be kinetic energy minus potential energy in general. You can compare the kinetic energy of Lagrangian as half mv squared, so velocity squared this one. For the second term, it will be including this with this, okay, and velocity is phi dot square. So this is how masses you got for two different terms. So p theta square upon 2m, that is the kinetic energy. For the Hamiltonian part you will write, so m will be with the theta square part, that is 2ma square. Okay, that's going to be in all the options we are gonna have. Next is p phi square upon 2m, that is again ma square sine square theta. So this is how we are just gonna have, plus potential energy, that is mga cos theta. You can see the option B is just matching with the exact expression, and that's how we can easily get that option B will be the correct one. If in case there is anybody having any doubt in this part or any of the questions I have discussed till now, just mention it. I'll be talking about that. But if everybody is getting it, that's great. We can take the next question then, guys. But if in case you're gonna have any doubt, just mention it. I'll be talking about that too. Or here's the next question for you. Try now, let me know as you will get it done. That what is the right answer according to you? As you will be getting it, you can mention it in the comments. Try it now. As you will be getting the answer, just mention it in the comments. Even I'm gonna continue the discussion about it, guys. So basically they are talking about the canonical transformation, for which the Poisson bracket of capital Q and capital P with respect to the small q and small p, that is delta q upon delta q, delta p upon delta p minus delta q upon delta p, delta p upon delta q, that must be equal to 1. If it is giving you the value 1, it means it's a canonical transformation, but they have already mentioned it. The transformation is canonical for what values of alpha and beta. So we'll be using this condition, and then we will be getting the alpha and beta values after applying this condition. So let's differentiate the q, capital Q with respect to small q, capital P with respect to small p, and then vice versa, q with respect to p and p with respect to q, and equate it with 1. And also 1 can be written as q to the power 0 because you are just having the q as having some powers on it. So you will be able to compare the powers of q at the end, which will be helping you to get your final answer. Check it out and let me know what is the right answer according to you. If in case you will be having any question or query, you can just mention it. We'll be talking about it too. And just in some time, our next session will be starting, guys, and that's going to be of quantum mechanics, where we'll be taking most important questions, concepts and tricks of quantum mechanics too. And today in the evening time we will have our mathematical physics marathon session too. Very good, and rather that's great. It's option D which will be the correct one. If in case there is anybody who is gonna have doubt still here, you can just mention it. I'll be talking about that as well. But if every concept and the point which we have discussed here in the session is clear, that's great, guys. And as in the starting of the session I've told you about the upcoming new courses too, that soon we are going to have so many new courses starting on Unacademy. So if anybody wants to join and attend the regular live classes of well structured and well planned courses by the top educators, then guys you can have a look at the details given here regarding the iconic subscription, the plus subscription, the light subscription, and the difference between the these different subscriptions. Whatever you find more beneficial for you, whichever subscription you can take, okay, like whether plus or iconic, and these will be helping you a lot to take your preparation to the next level under the guidance of top educators. Even now the notes are available on the learning app, which will be helping you to do the best preparation with the live classes, the well structured and well planned courses, and all these important things. And one more thing, guys, you can use and apply the referral code, that's Anjali Alive, as mentioned here on the screen, to get the discount in the total subscription amount. So this is how everything is gonna be helpful and will be helping you a lot to take your preparation to the next level. Let's keep it this much right now. Thank you so much everyone for joining this session. We'll be having so many other important sessions which will be starting soon too. So let's keep it this much right now. If in case you're gonna have any question, query or doubt, just mention it. I'll be talking about it too. In upcoming days, so many new courses by the top educators, the new batches, and all these important sessions will be starting, which will be helping you a lot to take your preparation to a very good level. Okay guys, so I hope now each and everything is clear to every one of you. But if in case anytime you will be having any doubt, difficulty, or anything which is not gonna be clear to you, you can surely let me know about it, and I will try to discuss those points as well. Thank you so much everyone for joining this session.